Hello and welcome to this video about SolidThinking Compose. We will cover some more advanced matrix operations in this video. Let's get right into it. So we have our console fresh, new, and we will start with a matrix A, which is defined as 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say we want to calculate the maximum value of this matrix. So we can say max of A. This will result in a column, in a vector with the maximum value for each column. So first column 7, second 8, third column 9. And if I want to have the maximum of this vector, I can just simply say maximum of A, and this will result in the one scalar maximum value of the matrix A. I can also do that with the minimum value, just say min of A or min of A. That's also possible. Same goes with sum and products. So for example, sum of A will give me the column-wise sum of the matrix, and sum of A is the sum of all total elements of the matrix A. Alright, we have the product left, product of A, again, column-wise product, and you can guess product of A is all elements multiplied in total. Alright, so that's maximum value, minimum value. Then we have dots, dot products, and the cross product. You can also make that very easily. So for example, let's put some vectors. A equals 1, 1, 2, 3, and B equals 4, 5, 6. And let's say we want to calculate the dot product. We simply say dot A comma B, and this is a dot product. So dot product means that you have row-wise multiplication, so 1 times 4 in this case, plus second row multiplicated times third row multiplicated, and that's the dot product. You can also do the cross product. Cross products are mainly used, for example, to get a third vector which is orthogonal to both input vectors. For example, I have x equals 1, 2, 3, so 1, 0, 0. Test it if this works also with row vectors, and y equals I think it will 0, 1, 0. And if I have the cross product of x and y, I think this will give a matrix. Yeah, but in this case, yeah, it's the correct answer. But I think it's more adequate to have a column vector here. So just 1, 0, 0, 0, 1, 0, and C would be the cross of x and y, and that's 0, 0, 1. So you can see that the C axis is perpendicular to the x and the y axis as related here. Then another thing is we can also use rank calculation and the determinant of a matrix simply by, let's say I have matrix A is still in place. Yeah, so I could guess, for example, rank of A is 2. So we have it's not a full rank. Well, let me change that quickly. Maybe we have 1, 2, 3, 4. That should be full rank. So full rank means it's the number of rows of this matrix. So meaning that it has no equations which are dependent from each other, saying the same thing. And with a full rank matrix, we can also do this kind of equations, like if you have an equation a times x equals b. So we have the matrix A, x is what we want to know, and b, for example, could be 2 semicolon 2. And if I want to have x, which gives b when multiplied with a, I can simply say it is a, x equals a backslash b. So this is this left-hand side matrix division. This result in -2, 2, and we can test that. If you just say a times x, we get 2, 2, and that's the same thing as b. All right. So that's the matrix calculation, how you get for simple linear equation systems. And the determinant is equally easy. Just say determinant of A, and here is your determinant. For 2 by 2 matrix, it's 1 times 4 minus 2 times 3. So 4 minus 6 is -2. So that's the determinant. Now, for the last thing I want to show you is how to get an inverted form of a matrix. There are 2 ways, and I will also show you how to measure time, how long it takes Compose to compute a certain statement. And for this you can use tick and tock. It's like your clock. Tick is start, tock is stop, and the output will be that it says how much time elapsed between those two points. Alright, now let's create for that reason a rather big matrix, because else it would say just 0 seconds for each calculation. So d equals rand 500. So that's a rather big matrix. And here is some special, here you can swipe through the matrix with up and down keys. And you have to press E to exit and make another statement. So our matrix is D, and we want to invert it. So invert D would be the statement. And before I do that, I say tick, semicolon, then the statement, and then tock, and semicolon. And what did I do wrong? Inverse. What? I forgot a second semicolon. So you have to put inverse D semicolon, because it's a separate statement. And here you have it, elapsed time is 0.027 seconds. And you can also do that differently. You can also have your inverted matrix form by doing this. I just go to the same command, and I will just divide, left-hand side divide D by an identity matrix, I 500. And here you have it, you have some different values in time. Depends on the values in the matrix, but there you have it. So that's about it for this video. Thanks for watching. I hope you liked it. Leave some comments down below, and I hope to see you back soon. Thanks for watching.